Hi everyone. So in this lesson I'm going to be going over how to figure out the equation of a circle, and we're going to be talking about questions related to the equations of circles. Okay, so the circles that we're going to be covering are all going to have a center at 0, 0. At least in summer school, this is the only type of circle that we will cover. It's possible to move circles around the plane so that their center is not at 0, 0, but we're only going to look at the ones that are at 0, 0. Okay, so what you're going to have to be able to do is explain why this equation works. Why does x squared plus y squared equals r squared define a circle that has a center at 0, 0? Determine the equation of a center. Determine the equation of a circle with a center at 0, 0. If I give you the radius, so I can give you r and you have to tell me the equation, or maybe I can give you a point x and y and you have to tell me the equation then. And then finally, if I give you an equation of a circle or a drawing of a circle on a grid, and I tell you a point on, and if I give you a point, x comma y, you have to tell me, is that point on the circle? Is it inside the circle? Or is it outside the circle? Okay, so that's what we're going to be covering. This is a pretty short one. Okay, so the equation of any circle with a center at 0, 0 can be written this way: x squared plus y squared equals r squared, where x and y are points on the outside of the circle, so somewhere along the circumference, right? Remember, circumference means like the perimeter or outside of the circle. And where r is the radius of the circle. So again, if you remember, the radius is the distance from the center to any edge of the circle. That's what defines a circle, right? The fact that any point here can be connected to the middle and the distance is the same. That's what a circle is. And remember again that these circles are going to be centered at 0, 0. Okay, so why is this the equation of a circle that has a center at 0, 0? Well, it makes sense when you think about it, because you essentially can form a right angle triangle using that point, using the radius, and using an xy component. So what you're going to see here is, hopefully this is going to look very similar to what we already did with the distance formula, because the reasoning here is, it's almost the same. So let's take an example. Suppose we have a circle with a center at 0, 0, and we have a point 3, 4 on this circle. So I could have chosen any point on this circle, but we'll just choose 3, 4. Well, what does 3, 4 mean? Well, it means that from the middle you have an x distance of 3 and then a y distance of 4. You have a run of 3 and a rise of 4 to get to 3, 4. And if you make the connection directly from the middle to 3, 4, then you have the radius. So again, you'll notice this forms a right triangle with a hypotenuse. And we know how to relate the hypotenuse to the other sides when we have a right triangle, right? That's simply c squared equals a squared plus b squared. Or in the case of this triangle, it will be the radius squared, right, 5, equal to the run squared, which is your x, plus the rise squared, which is your y. Okay, and notice that that's true no matter where the point goes on the circle. Even at these points, you don't actually have a triangle at the cardinal points, right? The points sort of on the north, east, south, and west parts of the grid. But they work there as well because you have no x or no y component, so your radius is only the remaining one. So for example, here, you don't have any y component if your point is right there, right? You're not moving up and down, you're only moving left and right. Well, how much are you moving left and right by? Well, the radius. If that doesn't make sense, don't worry about that right now. That will be important in grade 11, but we're not going to use that idea in this course. Okay, so the point is, you can make this triangle. So you have a hypotenuse, and you have an x, and you have a y, and the relationship is just the Pythagorean theorem relationship. So that's where this equation comes from. Okay, so now let's use it to solve a couple problems. Find the equation of a circle with a center at 0, 0 and a diameter of 12 units. Okay, well, if the center is at 0, 0, we already know the equation will take this form. And we know the diameter is 12 units long. So you maybe remember your terminology here, but if you don't, a diameter is the distance across a circle that goes through the middle. So your diameter is essentially made up of 2 radii, right? It's the radius twice. So you can say that 2 times the radius gives you 1 diameter, right? The diameter is half the radius. So if our diameter is 12, then that will mean that our radius is 6, right? The radius is half the diameter. So once you have that, it's really very easy. All you got to do is plug 6 into the radius. You can simplify 6 squared to 36, and that's it, right? This is like the equation of a line. When you have the equation of a line, y equals mx plus b, you have to find m, you have to find b. You don't really find x and y because those are numbers that whoever is working with your equation can plug in. So you only have to really say what r is. So x squared plus y squared equals 36 is actually the answer to this question. All right, last question. Example 2. Is the point 10, 3 on the circle, x squared plus y squared equals 36? Is it outside the circle or is it inside the circle? So just to clarify, what do we mean by inside, outside, or on? Well, I have a diagram here to kind of show you. So on the circle means it's somewhere along the circumference. So it's on that red line somewhere, or on that red circle somewhere. Inside means it's inside the circle, right? So it's closer to the center of the circle than the circumference. It's inside. Outside means it's, well, outside of the circle, right? So it's the point is farther away from the center of the circle than your circumference. Okay, so pretty easy. How do we know if this point is on the circle, outside the circle, or inside the circle? Well, what we can do is we can calculate the radius of this circle, and we're going to say that we know that 10, 3 is on some circle with the center at 0, 0, because no matter where 10, 3 is, let's just say it's somewhere over here, you could still draw a circle that would be centered in the middle that would contain that point. So 10, 3 is on some circle. So let's see what circle 10, 3 is on. So we do that by subbing 10, 3 into the circle equation. 10 squared plus 3 squared, right? So your x squared is 10, your y squared is 3. Sorry, your x is 10 and your y is 3. So we plug those in. So 10 squared plus 3 squared equals r squared. So 10 squared is 100, 3 squared is 9. Add them together, you get 109. So if you want the radius, you just take the square root of both sides, and you get the square root of 109, which is approximately 10.4 if you do it on your calculator. So what we're asking ourselves then is, okay, 10, 3 is on some circle, and the radius of that circle is 10.4 units long. Well, let's compare that to our original circle. So our original circle, the one we want to know if the point is on, x squared plus y squared equals 36, well, the radius for that one is just going to be 6, right? R squared is 36, so r will be 6. So what that shows you is that the radius of the original circle is less than the radius of the circle that 10, 3 is on. So what does that look like in a picture? Well, it looks like this. This is your original red circle here. It looks a little smaller because the scales shrunk a bit, but your original circle has a radius of 6, and the circle that 10, 3 is on has a radius of about 10.4. So we can clearly see that if that point is on the blue circle, then it is outside of the red circle. Or to make matters simpler, if the radius from the circle that the point is on, 10, 3, so if the radius of that circle is bigger than the radius of your original circle, then that means that 10, 3 is outside. If it's smaller, then that would mean that your circle would fit inside here, and the point would be somewhere along that circle. So then you would say that that point is inside the red circle. So if your radius for your point is smaller than your radius for your original circle, then we can say it's inside the circle. If they're equal, well, then that means that there's only one circle, and the point is on that circle. Okay, so really simple. I've summarized it here. If the radius is less than the radius defined by the circle, right? In other words, if your point creates a radius that's less than the radius from this circle, then we say it's inside the circle. If its radius is greater, then it's outside the circle, and if it's equal, then it's on the circle. Okay, that's basically it. So again, back to your learning goals, you should know where the circle equation comes from. You should be able to use it to find the equation of a circle if I give you a radius or if I give you the xy coordinates. And then finally, you should be able to use the equation of a circle to see if another point is inside, outside, or on that circle. Thank you.